Right, we are trying to make graphical commands that work in BASIC, and we got up to, we did the char command, the hchar command, which is double I characters, and we did the sprite command, which allowed us, I think, to position the sprite. Where is it? Oh yeah, position the sprite and colour it. So let's keep on the sprite theme, and I had mob and mob color. So mob allows us to specify what the sprite is doing. So sets the pointer, turns it on, sets the expansion at X and Y. BA, oh, background, that's the background, isn't it? Background and multicolor. So that's what basically it sets up the sprite. So that's what we'll do, and then once we've done that, we'll get onto the fill command, because that's going to take a while. That is, to try and sort that out. Might not get it done today, but we can try and tackle the fill command, because I've got in the code, I've got sound, I've got voice, put, I think that is to save the bitmap, retrieve, I think that's to load the bitmap, the bitmap in, and fill. I mean, we can't do pen because we ain't got a light pen, so it's not worth doing that. Or paddle, because we don't have paddles. So we could try and tackle fill and see how far we get. But yes, right. Let's create a line in here. So 17th today. Right, so the first one we'll tackle. So these should be pretty easy, because it's only byte gain. Let's do mob. Let's do mob first, because by the looks of it, it's not going to be that bad. He says. Oh well, here we go. Right. New file. Let's copy a header from somewhere else. Right, mob. To set up, isn't it? To set up. Right. So now M/O. Do we have M-Shift-O? Let's have a look. That's not the keyword, is it? No. Here we go. Basic 2. M-Shift-O. No, so we're all right there. Right, so we can definitely do M-Shift-O on this. So, but I don't know why. It's only 3 characters. Right, and the commands here are sprite number. sprite pointer. What's that? Oh yeah. Enable, disable. What else we got? Oh, that's it. Expanded X enable stroke disable. Expand. I better do it properly, Anna. X expanded. Head phase. X expanded. Well, that's how you spell it, isn't it? That's how you spell it. Expanded Y. Enable. What's next? Background. Right, I'm not sure about this. I'm not sure if it's background priority that you have to switch it on for background priority, or you have to switch it off. I'm not too sure. We'll find out. And then multicolor enable disable. Right, so mob. So it's basically mob sprite number. Sprite number. On stroke off. Well, it'd be 1 or 0. So on stroke off. Well, everything's on or off. So enable, comma, X big, Y big, background, and multicolor. Right. I think it's 1M. Thought it was. So basically, we're going to nick all this out this sprite, right? Because quite a lot of it's the same. So we'll grab to there. We'll grab to there because we can nick all the rest. So the first thing we need to get is the sprite number, which we've already got here. So we can get the sprite number, compare it with 8. If it's less than, it's valid. If it's greater than, we do an illegal quantity error. And next one is we need to then get the enabled. Now, the enabled is going to be, if I think right, but first we need to store it. Yeah, so we're storing it in the same place anyway. Then we're getting a comma, and then we are getting another cat, and we're not getting a 2 byte this time, we're just getting this. We're getting a single byte because this is sprite pointer number. And of course this is in X, so transfer X into A. So now we're going to store the pointer in its relative part, yeah? So LDX AXLO, that's the sprite number. And then store it. Now I should have the pointer set up. I think I've got the pointer set up. Might not be in there though. Where are we looking? Oh, it's getting so big, I don't know what's going on. Oh, try there. Is it in there? No, it isn't. That's alright, we'll put it in there. Oh, it's definitely not that, it's that. So that's 7F8. Grab that. And then store what's in A in that, comma, X. So that sets the pointer. Oh. We've also got to put it... Oh, I forgot about that. I forgot about that. Because if we're in graphics mode, the screen's in a different position. I'll have to... Hang on. Where's Sprite? We still got Sprite on here. Do we store? No, we don't. We just set the X and Y. Oh, okay. So we don't need to worry about that. So this is for in normal text mode, and this is in high res mode because we moved the screen to the third bank because we're using the third bank to store all the high-res graphics. So the sprite pointers will be in the same place, relative, but there. And because we don't actually change where the memory location where the screen is, it's still at 8400 when we work it out. Right, so what's next? What are we doing next? 2848. What's 2848? D1000. All right. Plus 21. God, John, what are you doing? Right, so we've done this. 15, DO15. Time to get the book out. Time to get the book out. DO15. Can't remember what DO15 is. Oh, I saw it there. Come on. Too far. Here we go. Oh, sprite enable. Right. So I'm loading it in and storing what's... I'm loading it in and storing what's away. and then I'm doing this mob get. Okay, right, let's code that. So we're loading in. Ooh, where's me? Where's my memory locations gone? Fix it. There it is. That one. Store it into com AY, and now we've got this routine called mob get. Right. So let's put that routine in. Right, mob. I'm not going to call it mob get. Mob param get. That'll do. That's basically does it. Right, so we're JSR. So the first thing we do is we move on. Now, did we say get comma, get byte? So technically we could say get comma again, because everything's going to be separated by commas. But what younger me did was just run the JSR 0079 routine. Oh, I do get comma next. So we're going to have to do that. Now, I'm not sure if I've got that in my routines. I don't think so. Oh, yes, I have. So basically, what's that doing is because we destroyed A here, we're re-establishing A from the. So what we're doing was we're going back to the basic program and getting that character back out of the basic program so we can work with it, and that's where check comma comes into it, because that's what will do it. Then we'll get the byte. So this get number from 0 to 255. Because we're gonna, for all these now, it's going to be 1 or 0, 1 or 0, 1 or 0, so it's just a single byte. And then we're going to check that it's a valid number, so cpx #2 and branch if carry clear +3. I'm just putting +3 in a moment until I fix so. And then I think that's a legal quantity, B248. B248. I think that's a legal quantity. Yeah. So if it's so it'll accept 0 and 1, but as soon as it gets to 2, that's it. End of story. So so we'll do to there. And we'll make that jump. So we jump round it. Hello guys. No one did pay attention to chat because I didn't see you was chatting away there. Evening, is that C# you're programming? No. You can use that for making a
Oi, John, pay attention to chat.
It's a bit late now. Oh, hey Arthur. Any news on a new release? Any news? Hey, bumbling coder. Evening. Right. You've been collecting bugs, so okay. Oh, okay. Well, this is I'm using beta 6 here, so I think it's beta 6. Yeah, beta 6. So I'm still using that. I haven't come across anything yet, other than what I told you. Right. So B2, so that's lead quantity. So if it's right, okay. CPX hash 0. Am I making a kaleidoscope comment? We could. Command, we could. But not today. Right, okay mate, cheers. I will use that as soon as I get it. Right, so now we are checking for 0. So we branch if equal, but it's plus 14. So we'll have to figure that out. So if it's 0, it means it's going to turn it off. It's going to turn whatever's off. So I suppose we could call it at disable. Yeah, at disable will do it. So if it's equal to 0, we're going to the at disable part. But if it's equal to 1, then we're going to activate whatever it is that we're going to be activating. Right? So the question is, that code has been run twice. That code has been run twice. Okay. Work out sprite bit. So let's see, say subtract com ax low, which is the sprite number. Transfer a to x. Oh yes, so the end result is x. So JSR work out sprite bit. So x is the value now. So we've got x, that's our sprite bit. So that's the corresponding sprite bit. So we're going to load LDA, whatever's in AY, or it with byte mask, x. So that switches it on. And then we return out. Okay. So do the same thing, JSR work out sprite bit. And this one is now turning it off. So LDA byte mask comma x XOR 1, 2, 3, 4, 5, 6, 7, 8, and it with what we've already got, and then return. So the accumulator's going to have what's left. So we're putting it in COM-A, and then we do this, which gets our next parameter, and the result is in the accumulator, so we store it back into vic to, so that's the enable. Okay. Just checking that. Right, we don't need this. For that. Right, so the next one is 1D. 1D. I think that's the... Microman. Acmafin, how you doing? Right, DO1D is the horizontal expansion registry. So we're going to do the same thing again. So 1D, 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 1D. So we're going to do the same thing again. LDA that, store it in com AY. To be honest, we could do it in here. We could do that. Let's do that. So we load the accumulator with what we want and then let that do the rest. So it's effectively the same thing again. Right, this is going to be easy because we're doing it again, but this time it's Y expand, I think. Let's just make sure. 17. Yeah, that's Y expand. Yeah. So we'll do the same thing again. So the next one is 1B, which I think is, here we go, foreground display priority register. So 0, right, sprite, 0 is sprite appears in front of foreground, 1 is background appears before, right, so it's definitely the background priority. Yeah, so background priority. Right, so it's definitely that. So 1B, 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 that's this one. So we'll load it and then we'll save it. So that basic, yeah, background, so that's the right terminology, background priority. By default it's foreground. No. Sets the display priority of sprite. 0 equals sprite appears in front. Yeah, that's right. 1 background appears in front. Yep, that'll do. Right, so what's the next one? I think that's multicolor mode. 1C. Yeah, multicolor mode. Do this. One C, and then that's it. That's that command. That is that command. Right, let's put it in and find. Let's try it out. Tokenizer. So the text is MO capital B. Alright, Microman. Have fun. -1. And we need to insert the ink file into here. Mob command. Right, so I need, right, let's close this because I need some sprite data, don't I? I need some sprite data. Right. Test. There we go. Right, so I need... There we go. Export to listing. Basic data, start at 1000. Just the current sprite, please. Go. Et voila. Right, put that in Notepad so I don't lose it. Right, let's go back. Right, let's fire this up. Nearly pressed the wrong key. We have an error. Too many up. 31. Oops. Oh. He could say that, mate. He could say that. And C#, I think it is. Okay. I've got my byte masked the wrong way around, I think. Oh, there's no underscore. Mob command. No underscore. Oh. Now I've done the kick thing. F5. So we've got the sprite command and we've got the mob command, so we should be able to do this pretty quickly. Oh, why have you gone small? Oh, it's 2.4, that's why. Right. Edit. Paste. Oh. I did it again, didn't I? No. I did it again. Oh, look, even Notepad remembered from last time. Right. So, okay, so we need to read the data in, don't we? So, for I got it, 262 colon poke 1288 12288 plus, this is where I got stuck, wasn't it? Plus I comma A. Oh, I've missed something out.
Oi, John, pay attention to chat.
Okay. Thank you. Did I say 62? My brain is working on its own, I'm afraid. Well, I will have AMK points up. Like I say, I've been trying to learn Node.js, so I was hoping I'd be able to hook into Shallan's database, but doubt if that'll happen. Plus. There we go. Just use Excel, yeah. Right. So that's reading the sprite data in. So we should be able to use the mob command now. So mob 0, comma 192, comma, oh, I can't remember now. Where's the, so that's the sprite pointer, 192. What? Oh, it's on. Yeah, we want to make it big, both directions.
Oi, John, pay attention to chat.
No, not yet. We will do, because we need to test it out, yeah? But not yet. We're just doing the normal we're just doing the normal mode first. -5. Right, so Y background enabled, we'll leave that at 0. So we say that's off and say multicolored's off. So that should set sprite 0 to pointer 192, turn it on and make it big. Right, 30 is sprite, and this should move it. This should place it. So sprite 0, comma 100, comma 100, comma 2, which I think is black. No, 2, red. Right, let's save this. There we go. Okay, let's see if it does it. Syntax error in 20. Ooh. Did it tokenize it properly? Let's have a look. Right, so that's line 1. It keeps going, it keeps going. There, that's the end of line. Line 2. So this is line 2. Oh, it did tokenize it. Oh, you mean in the tokenizer? No, it shouldn't do. Right, because the whole point of the tokenizer, right, tokenizer, is you make the final character big, right? So it's shift B, because what you do is you're checking for the bit 7. So it's tokenized it right. It's tokenized it right because it's got DB. So it's tokenized it. So let's just check this out, right? Because it says DB. So if that's DO, D1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. Yeah. So it's tokenized it right. Space 0, comma 192, comma 31. Right, so what I need to do is we need to put a breakpoint in it. Where do I need to put a breakpoint in it? Where's the debug information? There. So let's figure out where I need to put the breakpoint. Right here. So we'll put the breakpoint there. So that's setting the sprite pointer. So we'll put the breakpoint there. So that's 90A2. So debug. Oh, that won't work either. A2, so that's where we need to put it in. Right, 90A2. There it is. Right, so we've put a breakpoint there. Come back here. Oh, God, that's slow. Wow. That is really slow. Hello. Right, so we're just going to do the mob command because we know it's that command that's causing the problem. So 0, 192, on, x, y, background, multicolor. Right, run. Ooh. Didn't even get to my code. So, oh, it didn't get to my breakpoint. So it's failing before then. Yeah, I'm good. How about you? Just trying to figure out what's causing this problem. Right. Mob. So it's somewhere around here. Where's the start point? Where's the start point? (908F). That's there. Right. Right, we'll run it again and we'll see if it oh, I'm coding assembly right now. Right, here we go. Right. So we've broke. So we'll tell it to go on. So that's got 0. So we're testing it with 8. It's less than. So it should continue. But that's gone to 9025. Have I coded it wrong? Valid sprite. Okay. Why's that gone there? Branch if carried clear to 9025. But it should have jumped to here. Valid sprite number. Have I got another valid sprite number? Oh. Oh. Dude. Arthur, you still here? Why did it not warn me I'd used the same label twice? Is that a bug? Yeah, I'm going to use a temp. I had the same label twice. And it did it on that one as well. And just in case guys who are watching, I've got the developer of CPS in chat, and this is a beta version that we're playing with, so there's bound to be some small issues that we come across, but that was an interesting run. Right, let's do that again. Right, debug. All right, mate. Right, that should have built it. Let's do F control load. Come on, load it in.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Mr. Casteron, thank you for following, mate. Welcome. I hope you're enjoying what I'm trying to do anyway. Right. No, let's run it. I have confidence it's going to work this time. Let's run it. Build, program, go. Oh, I've still got it open here. Oh. Okay. Let's do that. Any more for any more? Not in there. Do I double back on myself here? Nope. Okay. Let's try that again. Right. Right, for all those people that have joined and don't know what I'm doing, we are extending Commodore Basic. So we're writing Commodore commands in machine code to extend the basic language to cover graphics and sprites and stuff like that. So this currently we're trying to develop the command for the sprites. So here we go. Oh, and there we are. There we are. Victory. Right. Cheers, Gravy Defender. Cheers, mate. Thanks for the bits. So ignore the data statements. So we created two commands. We've created the mob. This sets up the sprite, and then the sprite command actually you can use the sprite command to move it around. Yeah. So if we wanted to say do 30 again, for I equals. There we go. 50 to 150. 40. I think that will go up here and do 40. And that will be I. And then 50 will be next. So it should look like that. We should now have a sprite that moves across the screen. There we go. So this sprite tells it where to place it. So this sprite command tells it where to place it. So this mob command sets it up. So it tells it that sprite naught, where the data for the sprite is. So what sprite physical location. Is it on? So if that was 0, that would turn it off. Is it big? X and Y. Is it in front? Which it is. So that's 0. So we could make that 1 and it should go behind. So if we make that 1 and then run it again. There we are, it's behind. Oh, is it? Yes, it is. Oh, thought that wasn't then. But it definitely is because the number there is in front of the sprite. Oh, I nearly went. Uh-oh, didn't work. But it's there. It's behind the text. So put that back to 0. Should bring it back in front. Yes, it is. So now we've got ways of acting on sprites. Now the problem is the only way we can change the colour is in the sprite one, which is the sprite colour. We've got no way of setting the multicolours for the sprites, and that's where MOBCOLor comes into it. So we've got another command that allows you to set the multicoloured part of the sprite environment. So what we'll do, we'll knock that on the head and we'll code that up. Now that's going to be pretty easy because it's just storing byte values in the right places. But we do check as well. My younger self actually did some validation checking. He was a clever person. Right, so inc mob call command. Oh, I spelt that wrong, didn't I? My brain's running at 400,000 miles an hour. My fingers aren't fast enough. Right, we'll nick the top bit and set it up. So this is MOBCOL, basic function to set up the sprite multicolor options. So the command will be MOBCOL, or we can't do M shift O, so it's going to have to be MO shift B. So the commands are, yours is running at 48 baud. Oh, brain. Yeah. I've been suffering it all day. I got a lot done. I put the JavaScript learning to one side today because I had to do some C# stuff, and I was on fire today. It was fingers couldn't keep up with the brain. Right, so the commands are so it's basically multicolor. Oh, come on. R1 and multicolor 2. And we spell color correctly. So MOBCOL, and it's multicol 1, multicol 2. Right, so basically we're just bringing in two values, so we can pinch that from here. And in fact, we can pinch it from here. Just grab this up to there and paste it in there. But this time we're not getting sprite number, we are getting color number 1. Comparing it with 16. Yes, we compare it with 16. This is a valid color 1. If it's anything above 16, we throw an illegal quantity error. So we then store this, store X, because that's where the value is, in vit locations, color. So back, so that's the, where do we store it? 25. Here we go, multicolor. Store it in there. Yes. And the problem, but you're going to get some minus AMK points if you carry on, mate. Go on. You're telling me I've done wrong? This? What does that mean? No? 16 is 16 colours, isn't there? Doesn't the sprite have access to all 16 colours in the multicolor mode? It's only the characters that don't, isn't it? Isn't it? 25. Here we go. This register sets up the colour that displays by the 0-1 bit pairing in multicolor. The default colour is 4. No. It's the sprite multicolor, and I think that's 16, mate. But we can test it. We can try it out. Right, so that's set up sprite multicolor 1. So then we check for the comma, and then we do the whole process again. So check for 16 if it's a valid color, and multicolor mode 1. And that's it. So we should be able to add that command now. So we're going to tokenize it. So tab. Put the address in. put the text that we want to check. And then add it to our base. Right. So that should fire up. Oh, I did F6, didn't I? F5. Right. Let's load Sprite in. And what we'll do is we'll set up on line 25, we'll set up the mob color. So we'll say we've got red, we'll have black and yellow as a tester, but then we now need to set the sprite as in multicolor mode, so that's the end one. Right, so run. We should end up with a multicolored sprite. Ooh. Let's just make sure I ain't done out wrong here. Stores that, checks that. Color 2. Okay, that's fine. Let's do a bit of a debug, find out what's going on. I'll be glad to get the next beta mate that allows the breakpoints to transfer across. So we're looking at 910F. Oh, that didn't work, did it? Because I'm in the wrong one. F8. Cool, this is going to be slow, isn't it? Control R. That should reset without breaking anything. There we go. Right. 10. Mob. Call. 0,7. Right, let's put a breakpoint in, which was 910F. There. Right then, let's run it. Let's find out where the problem is. Oh, it didn't get there. Didn't even get there. Where's memory view? Did it tokenize it? Oh, it's tokenized it to DB. Oh, It's taken the first three. Right, okay. Okay. Right, what's happened there? It's taken this first. It's matched with that command first. So when it runs through, when the tokenizer runs through the basic program or the line, it tries to match the line. And what it's done. All right, mate. I'll be great. It'd be great if I can set breakpoints again. But what it's done is it's tokenized to mob and not MOBCOL. So what we need to do is we need to swap these two commands over like that. Like so. So what it'll do, it'll try to match to that first before it comes to here. But to be honest, I think it will still match to that. It'll still match to that. What did I call it in my code? Did I call it mob color? Let's have a look. What did I call it? Ah, okay. Okay. We'll try this. We'll try this. We'll see if it works doing this. Mr. WauloK, coffee good today? Good. We just got a bit of a problem with commands merging. I'm just seeing if we can do something with it. Yeah, that's now saying mob. Right, so let's do that again. 25 MOBCOL 0,7. Right, let's just do a quick monitor on that just to make sure it's tokenized it properly. Right, so we're on, get that out of the way. We're on line 25. So this is line 10. Line 10, so we're looking for a 0. There. So this line 20. DC. Oh, it looks like it's done it. It looks like it's done it. Looking for a 0 again. There. DB. Oh, here we go. We're on a winner. Yeah. We're on a winner. Right, so this should now work. So run. And what did I forget to do? I forgot to put multicolor on. Has WauloK got a Twitch? Has he? Oh, there it is. Oh, he's offline, look. Right, let's try this again. Multicolor mode, please. Yes. Yes. Right. Mr. AMK was concerned the colours wouldn't go up to 16. So let's write, what's 15? And we will do 12. So they're the two colours. Right, let's run that. Yep, they're right. 12 and 15 is light and dark grey, isn't it? So now we can specify. So once we turn multicolor mode on, we can, if you can specify the colours for the mob, then that will fill out the colours. Cool. Right, I'm going to save this as sprite 2. So we've just added mob and mob color. So mob sets up the sprite. Mob color changes the allows you to set the multicolor part of the sprite, and sprite allows you to act on the sprite. So they're the 3 sprite commands. Now, I'm not going to go into sound. Not yet. So fill. Right. Fill. So I've got to try and explain how I did fill. So I was looking at the code and to see how I've done it, and this, if I can get to the code again. Here we go. So this is how I did fill. So let's load something in, try and see if I can try and explain how I did fill. So imagine this as the screen. So if we draw 2 shapes. Right, so a circle there and a circle there, right? And let's say I wanted to fill that bit, yeah? Well, what I used to do, yeah, that'll do. So let's zoom in. So this is the space. Now, what I did there was I set a point that I wanted to start to fill. So let's say I wanted to start to fill from that point there. Can you see that, by the way, guys? Can you see that? Yeah. Let me. Can I make this pencil bigger? Right, so what I did as a kid was I worked left this way in a straight line. Ignore that I'm not drawing a straight line. Worked pixel pi pixel this way, testing to see if the pixel's blank, yeah? And if there wasn't a pixel in it, I carried on going and carried on going until I hit a pixel there. Then I would stop. Then I would go back here and go the other way. Oops. In a straight line, like so, until I hit that. And then as you check it, you fill the pixel in, yeah? So then I would go up another pixel, do the whole thing again, and I would work my way up until I can't draw a straight line, until I hit the top, right? And because I couldn't go anymore, I stopped. Then I come back down here and I did the reverse this way, down here, until I hit a pixel and then stopped.
Oi, John, pay attention to chat.
Oh dear. So you only ended up with up to there filled and up to there filled. And so to fill the gaps in, you would fill there and you would fill there. So you would end up with 3 fill commands to fill the gap. Right? So I can demonstrate it in here. So let me fire up Vice again. Only you, mate. Only you, mate, could think that. Get me banned. Right, so I'm going to attach my master disk. Yeah, it's in there. So I'll attach that, and it's 19. Right, load 19. Load 19 with star. 8, 1. Right, so this is the original code I wrote as a kid. Right, let's fire it up. So this is the code I wrote as a kid. March 1985. Ah, such a long time ago. Such a long time ago. Right, so 10. Graphic. 20. So we'll excuse me. We will draw the 2 circles. So you wasn't born then, really? Yeah, right. So 75, comma 100. We'll make this one 75 wide, starting and going to 361, and then we'll draw another one. So circle. We'll make this a bit further on. So 100, comma 100, comma. We'll make it smaller. Right, so these are the 2, let's say we've got 2 circles intersecting each other, yeah? Oh, it's not quite what I wanted. I'll have to move it a bit. Oh, but then again, yeah, that could be right. So, let's say we're going to fill from a point there. So if that's 100, yeah. So let's fill 100, 100. So it's going to be 120, 100. Right. Now this shouldn't fill that centre bit. It should miss some. There we go. Well, this is the point, mate. When I was a kid, didn't even think about anything like that. So what I did was, to solve it, I would either work out the point that would do it right. So the point that would do it right would be there, or just figure out with points that to fill in the bits. Because if you had a funny shaped shape, then you would have to work out. But as a kid, there you go. As a kid, it didn't bother me. But as an adult, of course we're older and wiser, and we should be able to figure this out. Now, I've been reading this book. And he's got Mr. Nick Hampshire has got a fill command. He's actually got 2 fill commands, and the first fill command, where is it? He's got fill and defill. And fill is a normal fill command, which is the same as mine. Just fills the available area, and I don't think it does any recursion. I'm trying to find the fill command. Oh, when you want it, you can never find it. Ugh. Anyway, so I've been reading this book. Alright? So, here is his fill command, the flowchart of the fill command. So let me just blow that up for you. There we go. And he's got a queue system where his fill command is XY, 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 XY. So you can set, like I did was 120, 100, and then you could put comma 100, comma some whatever the Y value is to fill the top bit and the bottom bit. But he's doing exactly the same thing I'm doing. He's checking for the extremes, then draw it. Do the next pixel up, check for the extremes, draw it. Next pixel up, check for the extremes, draw it. And he carries on and carries on and carries on and doing it. And so he ends up with spacers. Now he did another one called D-fill, which is diamond fill, which this is it here. Now D-fill performs exactly the same as fill, except that it uses a different method. Whereas fill fills horizontal lines, D-fill fills in a diamond shape from the start point, right? And the flowchart for this, here we go, is a little bit more in depth. So what he's doing is he's checking to see if the point is plottable. If it is, can you plot above it? Yes, you can. Store those coordinates on the queue. Yeah? Can you plot below it? Yes, you can. Store them on the queue. To the right, yes, store them. To the left, store them. And then he loops back round. Is the queue empty? No, it isn't. Right. Pull the first value off the queue. Check north, south, east, and west. If you can do it, put them on the queue. And as you do it, you see, you're filling every bit in as you go through it. And so you end up, the way it works, it does diagonals. But each point is checking in all directions, right? So every time you plot the point, you check the direction, check it again. And it means that you've got to have a big queue. You're going to have a big queue, because if you want to fill a large area, then yeah. So we can do the same thing with the horizontal line, right? Because what we can do is, as we're going up, we can say for each point, can I go up? Can I go up? Can I go up? Can I go up? And if you say yes, then we store it in the queue. We store it in some sort of queue. And then, so if our stop point is there, but we've still got space here, because we've checked that way, we know we can go up. So it's just a case of where do we start? You know, picking from the queue, where do we start? And we could do it pixel at a time or something like that. But what I thought we'd do to start with is, let's just put my fill in that I did as a kid, which has its problems, but it does the job. So it's essentially this, yeah? It's essentially this, and then we could try and modify this to check for spaces that we can do. I mean, the diamond one's great, but it's literally sort of doing that, yeah? And it's only storing in the queue where it can go next, right? We can do the same thing here, yeah? But instead of doing testing all four, because we're doing horizontal, we're testing the extremes on the horizontal anyway. So all we need to do is just store the a value that allows us to go up again. So we could say find the first one that goes up and say that's our start point, because then we would go there, but immediately it would fail because it would hit the top. But as we've gone along, it would have picked another one up and picked another one up and picked another one up, and the only time it would fail is when we've actually filled the line in, but every pixel above it is filled in, so it would never store anything on the queue. So this is what I thought I would do, is do the way I did as a kid first, and then evolve it so it would fill that bit that we've got left over. So that's what we're going to do. No, cancel. So this book was really good because there's some commands in here that I think we should nick. Like, I mean, not nick the code, but nick the command and do it in our own way. So he's got in here. I mean, he explains the wedge. I mean, he's done it in a weird way as well, which made me wonder. But he's got, right, these are his commands. He's got clear, graphics, sprite, off. That's to turn a sprite off. Place, polygon, origin, and he's got it where you can specify where the origin is. Our origin is in the bottom corner, 0, 0, and then goes out. So he's got it in his code where you can actually specify where the origin is. So you could put the origin in the middle of the screen, yeah, and have X, and the middle of the screen is 0, 0, and then do it either way that way. Then he's got shape, G-save, G-load, circle, screen, border, point. They're all the high-res stuff. And then he's got the commands for sprites and other things. So we've got clear graphics, norm, which is my screen. He's got screen and border, so they're setting the screen colour and the border colour. He's got plot, which we've got, draw, which we've got, character plot, which we've got now, H character, but he doesn't have the double height characters one in here. Sprite collisions, I'm not sure, mate. Let me hang on. Defill. Oh, fine fill now, a polygon. Dog's peeking through the door. Circle. On, hang on, where is it? On and off. He's even got a command called mat to perform arithmetic operations on an entire array. Wow. What else we got? Origin. Oh, they're the 3D commands. Off. Turn off a sprite. Place a sprite. So instead of he's got a thing called place. So it's place sprite number XY. Then he's got sprite, and that defines the sprite, which is our mob. And then G-load, G-save, so that's the bitmap loading and saving. And then he goes into 3D graphics, where he's got basic commands to do 3D graphics, which I thought was very clever. So I might have a crack at that. And that's why I understand why he's written the matrix mathematics, because he uses it for the 3D plotting. So, you know, we could pinch some of these commands, because I quite like the idea of sprite on and sprite off. Full graphic scrolling. Ooh, that would be troublesome. But yeah, I suppose we could do a sprite collision, where it just reads the sprite collision byte and then sets variables. I suppose we could do that. Right, let's get cracking then on this fill, because it's going to be long. Right, let's grab this. Fill. Oh, better put the commands in, haven't I? So we've done mob color, fill. Right, this is a basic function. Fills in an area on the high res screen. Fill. Now I'm not too sure if we have a command F-Shift-I. Yes. No, we don't. Well, I never. Right. So F-Shift-I. And so the two parameters are X, which is a number between 0 and 319. And Y, which is 0 to 199. Right. Let's get started, because this is gonna get tricky. Right, let's get rid of some of these tabs. Need that, don't need that. Need that, don't need that. Don't need that. Don't need that. But what I'm gonna do is I'm gonna grab the start of draw. There we go, I'm gonna grab that. And gonna paste it in there. Because this is basically getting, so we know X is a 2-byte number, so we have to use the 2-byte register, and we'll store it in there, and we'll store that in there. So we're going to store X in XR, and we're going to store Y in YR. Right. This is where it gets all confusing because I don't know what I was doing. So my younger self loads one and then stores it in com AY. I will find out what that is in a minute, I suppose. And then he does JSR fill 1. So we don't know what fill 1 is. Oh, hang on. Oh, I think I know what it is. Yeah. But it's not left to right, mate. It's fill up. Because his next command is here. So that's fill down. Fill 1. So there's got to be, yeah. So my I keep saying he. It's me really in my youth. So that's the first pass, which is going up. So we're setting AY, which is increments of 1, going up, and then the second pass is going down. So fill 1. So this is actually the fill start. Do that there. Right, let's find out what this is doing. Oh, fill 1, fill 2, fill 3, fill 4. Great, great labels, John. Ugh, great labels. Right, so we're loading the start point. LDA com YR. Yeah, that's the start point, and we are storing it in. So that's our working variable. So now we've got fill 2. So I don't know what fill 2 is until we get there. So we're loading the X. So it looks like this. Right, so fill 2 could be the row processor. We'll see in a minute. We'll see. LDA com XR low. Store in com XX low. So that's moved the X into working storage. Then this is fill 4. So I think this is fill row. So we'll leave that there like that. In fact, we'll do that. I think that's what that is. I don't know what 4 is, but we'll see what it does. Right, so we're loading the working X. And we're storing it in what we're going to be using to work out the pointer. So that's now, oh, and we have to do it with the get Y as well. Right, then we work out where that point is. So that's what JSR place does. That works out the byte that we need to look at for that point. Now we are removing basic. So we've paged out basic. And why am I doing that? All right, I will let me. So what he's doing is this. So he's loading X, then he's loading the byte mask, X, and then LDY #0, and it with 245. What's that? That's 245, isn't it? Yeah, it's that. Doing that, then comparing it with byte mask again. Then he's doing branch if equal to fill 3. Right, so he's loading the byte mask, then ANDing it with the memory location, and then comparing it to see if it's the byte mask. If it's equal to the byte mask, if it was equal to the byte mask, it would be set. Doing this in many places as well. This could be a routine, but I'm sure Point is doing that, isn't it? Let's have a look. Yeah, Point's doing that. He's doing it long-winded, but he's doing it. But we'll make this a function. I don't like the fact that there's let's just make sure. Fill test pixel. So basically it's all this. And then we'll do RTS. So here we would do JSR fill test pixel, and then we would check the end result. So if that is equal to the byte mask, so that means it's set. So I look at it. Right, so then he carries on, or I carry on. Load the working X low value. Subtract 1. Branch of carry set. Right. Then LDA so it looks like we're testing hey kebab. You suffering from my sort of syndrome? Right, so he's testing, or I'm testing, oh, I've got to keep saying, I've got to get this right. So my younger self is testing for 0, then branch if not equal +7, so we'll figure out what +7 is. Then he's loading exits low, comparing that to 0. Branch if equal +3. Jump fill 4. Now fill 4's here. Fill 4's here. So this oh, was the kebab imposter on Shallan? Alright. So this, because if we're subtracting 1, so this is testing fill, fill, testing left. Yeah, left. So that's testing left, so that's going to go back to testing left. So +7, so that's 1, 2, 3, 4, 5, 6, 7. So that's here. So this is going. So this is fill 3. So I reckon this is fill testing right. Right, let's see. Yes, it looks like it because he's resetting the values. But the problem is, I've got this here. And he's resetting, I'm resetting the values. Ugh. Right, LDA. So we're resetting the values. XR low is going to XX low. Right, so it's doing that. Then we've got fill 5, which is there, so we'll see what that is. And is he doing exactly the same thing again? XX low, high, da, 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 da. Yes, he is. Doing exactly the same thing again. Right, so this fill testing, where is it? There, testing the pixel can be a lot more. Because it includes all this lot. So we can put all that in there. We can get rid of all this. This doesn't need to be run all the time, so that can be put here. So we do the fill test. We do the pixel test, which is all this. And then we work it out. Fill 3, where's fill 3? What was fill 3? Oh, that's here. That was fill 3. So fill 5 is exactly the same as this. But this is now fill 6. That's going to fill 6. Oh, caps lock that. So it's hit the boundary on that side. If it hasn't, we're doing this. So we're doing this, so it's clear carry, add 1, branch of carry clear to ink pass by ink, yeah, then we load that, compare it with 1. Branch if not equal to continue, grab that, compare it with 64. Branch if equal to 3. So that's fill 6. So the continue, which is this, jump, fill 5. Now 5 is there, okay. So that's the same as that, I suppose. Okay, fill 6. What's fill 6 do? Oh, right, okay. Fill 6 or fill draw line. So this is where we're drawing a line. So he's setting the line parameters up. So he's LDA, COM, XX low, store it in COM, X2 low, LDA, COM, XX high, store it in COM, X2 high. So that's setting the that matey. So we're setting the x2 coordinates for the draw. So we need to do the same for the y as well. So LDA com YY. So that's the working y value. Store it in com y2 and to store it in com y1 because we're drawing horizontal lines. All right. We need to bring basic back. Right, so we bring basic back, and then we do draw plus 41. Oh, plus 41. Is that missing all our draw? Is that missing all our parameter getting? Here we go. Right, let's try and work this out. So draw plus 41. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. So it's there where we're starting to, so it's there where we're starting the testing of the orientation. Right, let's get to the draw command. Draw. So it's here. Draw line start. That's where we need to go to. So let's get back to the fill command. There we go. So we've set up the x, right, so we set up x1 up here. So we set up the x1 coordinates here, and then we set up the x2 coordinates here. So we've on the pixel line, we started testing that way until we couldn't go any further. So that's x1, and then we come back here and then went that way and tested until we couldn't go any further, and then that's x2, and now we're going to draw the line. So we draw the line, and then we change our working y. And that will either be 1 or 255. So compare hash 255, branch shift equal plus 3, jump to fill 8. I don't think we've been to fill 8 yet, which is down there. Now why would we go there? Okay. So fill 8 is this. So fill 8 is fill end, basically. So going back up to there. So at continue. Right, so we've tested with 255, so if it's going down, if it's subtracting, it hits 255, that's it, that's the end of the fill. Oh, here we go. Compare with hash 200. Branch if equal to no, it's not equal, is it? Branch if not equal. Can we continue? Otherwise, jump to fill end. Right, so if it's 255, that means we've hit the bottom of the screen and we finish. And if it's 200, that means we've hit the top of the graphic screen and we come. Now, can we continue? Is we're now, from what I can see here, is we're going to test the next line up. Is it clear? Can we continue? So we need to set everything up. So LDA fill end, is that the same? Hang on. XR low to there. So place. Right, so we can't do that. We'd have to set that, but what we can do is we can definitely do that. So we need to bank out basic again. Then, so LDA com XR low. So that's done that. Load YY, store it in Y. Right, so now we can do the JSR to here. Test the pixel. Branch if equal +3. If it's not equal, it goes to fill 2, which is right at the very top. So fill 2 is here, yeah, row looper. So jump there. And this would go, just the draw, yeah, so this comes back here. Fill end, right. Let's see if that, see if that works. Right. Here we go. F5. Do we get an error? Yes. Come on. Right. So we'll do the two commands. Uh, 75,100, 60,60, 0, 360. Um, 100, 100, 70, 70, 0, 360. Let's see how that looks. So, somewhere there. So if that's 75, that's one. So it could be 100, 100. Uh, 40 plot 100 from 100. See where the fill's going to start. So it's going to start there. That means we'd hit there and we'd hit there. Right. Oops. So 40 is fill. Right, let's see if it works. Why would that did yeah. No, it didn't start. It didn't look like it started from the center. No, I don't think it did start from the center. It didn't start from where we told it to start from. But to be honest, fill text. I don't think it detected the border. let's find where this where we can breakpoint this. Right, fill. So it's definitely on here. So we'll put a breakpoint. Put a breakpoint there. 9152. 9152. Mum's emailing me all the time. Right, Control R should reset it. We'll just do a box for the moment. Comma 10 to 100, comma 100. Somewhere in the middle. Right. 9152, wasn't it? Right, that's there. That's where we want it to stop. Right. Let's see what happens. Okay. Oh, I can't show it, can I? Because we're in bitmap mode. There we go. So we're here. This is where we are. Right. Go back to that. O2, 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 O2. Come on. O2A. Right. O2 C6. There we go. 32. 32, that's right, 50-50. So blanking out basic. Now basic's gone. Oops, got to follow it in there. There we go. So we're now working out the character position. Or byte position, I should say. Oh, this may take a while. Here we go. Right, we're back. So it's worked out the byte position, so that's now in F7. But it's at 0, 0, C0. It's at C0, 0, 0. That's no good. Put a breakpoint there, so it goes through it. It's still C00, so it's just working it out all to the same thing. So X is 1, so it loads 40, ANDs it, gets 0, so it carries on. I think there's something wrong with that place routine because we're getting the same number and we shouldn't be. Yeah, we're getting the same number. Right. Where's the place routine? So we're using COM-Y and COM-X and COM-X-low. Oh, using the wrong 0 page. Using the wrong 0 page. Right, let's try that. Right, let's see what damage we get up to. It's gonna fail and I'll show it out, I'll explain in a minute. But it should do a bit of it. There we go. See what I mean by it was going to fail because there was a gap. Like there's a gap in the circle. So we've now replicated what I did as a kid, is that we put the start point just off center here, and so it says right, I've finished, and so it's filled in what it can see. What we need to do now is, have we got time? Ooh, I don't know. What we need to do now is we need to be able to test when we're going up. We need to be able to test to see if we can go up another one, and we need to remember where that is. So there's two ways we can do this. We can, where we are, we can test both ways and also test above as well. It's just trying to shoehorn it into the code that has already been written. Because at the moment we're finding the extremes and then drawing a line, yeah. So we're finding the this point and then that's x1, and then this point and that's x2, and then we're drawing a line. So moving up, we need to. Ooh. How can we do that? How can we do that? Yeah, we had to plot the circle, we had to do maths, yeah. It's the fill that we're looking at. So the fill doesn't use any maths, it's just scanning for pixels. And then fills in what... Yes, the start position was somewhere here where I had the dot. So if I, hang on. So if I do 50 arrays, 60 plot, 100, 100, 70 arrays. So if I run it again, you'll see a white dot appear, and that's where the starting point of the fill was. There. So that was our starting point of the fill, and that's why it stopped there. And the thing what we need to do now is we need to say, oh, there's all this space up here and there's all this space down here. We need to be able to get to it. Yeah? Which means offsetting the X this way. It's just trying to work it out, how we can do that. Now, trying to make it work for all cases, we need to be able to. So we need to be able to do something. Let me see. How am I going to try and represent it? How will I try and represent what I'm trying to get across? Let's see how I know. Start point 50, 50 to 150, 150. Right, let's see what that gives us. Yep, that'll do. And then, so 30 line, 150, 50. No, that's wrong. 50, 150 to 75, 110. There we go. What are you guys talking about? Let's have a look. Are you trying? Think of filling a sine wave pattern. So it could do it in an up and down type approach. So draws first line. That way the paint cursor tracks the current paint line and can check for the same colour. I guess the worst case scenario would be to flood fill a maze there where the fill algorithm could need to support arbitrary backtracking, yeah, to be able to fill in the branches of the maze. I put a letter in. Put a letter in. Right. So the young John flood fill fails here. So if we say 75 110, so if we go 90 comma 120, this is where it fails, right? Oh, I actually got it inside it. Oh. 40. Let's do that. Oh, okay. I'm doing all right at the moment. Oh, God dear. Wrong X, wrong Y. Ugh. Right, this is where it, there we go, this is where it would fail. See, that failed. Yeah? Yes, so we need to test. The next line up, and to put it in. I missed a bit. Yeah, I missed a bit. So you're right, but in this scenario, we've got to, because we're working in this scenario here, it would go, oh, I can do that, I can do that, I can do that, and then skim up there. And here it would fail. And so what we need to try and figure out is we need some way of having a stack. Yeah, we've got to, I think we're going to have to scan two lines at the same time. So we scan the line that we're on, and we also scan the line that's up. And then we work out the extremes of the scan line we're on, and then we've already worked out the scan lines that are up there, but I'm still not sure, because it would need to be a stack, because in this scenario we need to record there's two areas. And I think that's where the diamond fill that Nick did in this book worked, because no matter where his point was, he was seeing in all directions if he could go. Yes, exactly. This is it. With the diamond fill, he was checking all the four possible combinations. Yeah, could it go north? Could it go south? Could it go east? Could it go west? And if he could go north, and so he was filling by point, not by line. Yeah, in the diamond fill. As the horizontal fill, you fill by line. Yeah, you find the extremes, fill by line. What we need to do is to be able to do the similar sort of thing that he did in the diamond fill, but try to make it as easy as possible for the line fill. So so how would we work this out? How would we work this out? We need a change in state. We need a change in state. I mean, we could change. We could change this to work as filling in point by point. Yeah. So as we're checking the line, we can check. So if we're going up, we can check above it and store that point into a stack. So when we come back to it, we get that point and plot that point. And plot the next, and then we check around it. Plot that point and check around it. Plot that point and check around it. But in this case, we are trying to find two coordinates, the extremes of two coordinates, and need some thinking. Definitely needs some thinking. I'm sure it can be done because, you know, Simon's Basic used to do it. I assumed that he was checking for the extremes and drawing a line. Maybe he'd filled in by pixel by pixel. Yeah. Yeah. Let's how would we do that? Because that would be a marker and then it would work that way. Oh. Yeah, it'll definitely need some thinking. I'm sure we can do it. I'm sure we can do it. It's just working out the points. The problem is we're not, because we're scanning here. We're only scanning this bit. So we've got to put something on the stack that says this is available. Yeah? And how would we do that? How would we do that? Oh, it's all good fun this is, isn't it? Yeah, or even a queue. Yeah, that we put it in one end and then pull it out the other. But it's some sort of recursion, really. It's just trying to work out when we're scanning ahead. So in this scenario, we'd start here. Oh, what, you mean this? This fella? Ugh. The thing that what we got to work out, right, is if we're starting here, let's say in this particular scenario we're starting here, which is roughly about right. We scan this way first. And so we're testing the top, we're testing, we're okay, stop. But we below carry on going. So then we need to say, ooh, what's going on here? What's this? Yeah. It's all set theory. I think what do I think? I could just pretend it's not an issue. My younger self did pretend it wasn't an issue, because my younger self would have just put a fill command in there and in there. Or even better, he would have done this. He would have done this. Right, so this would have been that. He would have done this. Oh, I missed it. I missed the point. Oh, it's too low down, that's why. It's too low down. Oh, filled in the wrong section. Filled in the wrong section. The difficult bit is figuring out how to only put the necessary points on the stack. Yeah, that's what I'm thinking about. Oh. I need it to be there. I need it just to be there. That's where I need it. Not hitting the point. So what have I done wrong? Oh, hang on. 75110. So that draws from this corner down to here. So I need, all right, I need X to be 51. and I need Y to be 149 or 111. That should do it. Going from the bottom up. There you go. That's how I would have done it as young me. But you're right. If we started putting every pixel that was available on the stack, we'd overload the stack. What we need to do is we need to find the outliers and use those. And that's the thing, is finding the outliers. Because what we need to do is we need to scan here on here and then go, right, this is a good one, this is not a good one, right, save that range. This is a good one, that's not a good one, save that range. Put those two onto the stack, and then we could use those two. So we could pop that one, which then would do this, and then it would only do this going upwards, yeah. And then when we'd finish there, we'd say, is there anything else in the queue? Yes, there is, which is this range here. And we'd go, okay, right, fill this one up, and it would carry on filling it up until it hit, and then we'd have nothing on the queue. So that's the thing, is trying to identify the range and put the range on the stack rather than point. And that's what I'm trying to work out now, is how can we identify the range of the two regions, right? Because when we start hit down here, it's just one range from there to there. Puts it on the stack, then we say, is there anything on the stack? Yes, there is. Right, we'll use that, and carry on, and to do that. It's all good fun. It can be. It can be done. It can be done. We just need to work out the logic for it. It's getting a bit late, but what we can do is I can think about it over the next few days. So when we come back next time or next Wednesday, we might have a plan on how we can do it, and then we can change the way the fill works, like we did with the draw, because we converted it from it using completely basic mathematics routines, and then we replaced the divide bys and all that by our binary divider, which made the draw a lot faster in drawing. So we could do the same with the fill. Is we work, I'll spend a little bit of time thinking through it and see if we can come back with how to pre-scan ahead. Yeah, so it doesn't matter if it's going up or down. Pre-scanning ahead just means it's looking at the line above the one it's currently on, yeah, and see if we can store the ranges that it comes up with, rather than storing every pixel. It says there was a range from pixel 51 to pixel 72. There was a range from pixel 75 to pixel 106. And there was a pixel from 118 to 204, and they're your ranges, and then they would be put on the stack, and then we'd work through those ranges that were put on the stack. And I think that's how we can do it, but it needs a little bit of thinking, because we need to scan ahead, yeah. So we need to draw the line that we're currently on, but scan ahead to find the ranges and pop them onto the stack. And then the draw routine takes those ranges off the stack and draws them, yeah. But then we still need to scan ahead, and so I think we'll look at that, and in the next graphics stream on next Wednesday probably, and see if we can make this fill a little bit more intelligent, and throw harder things at it, because I suppose I suppose, yeah, in the maze you would eventually do it, but the problem with the maze is, well, the problem with the fill, it's only scanning in two directions, yeah? So it scans up, once it's finished with all the up, it then scans down. Now with a maze, you would have to recursively scan up and down. But that's just making it too difficult. Let's just try and make it a typical fill without the recursive element in it, and see if we can do that. So I think that's going to be the topic of the next graphic stream, is how we can make this fill a bit more intelligent than it is at the moment. It just make what I did as a kid better. I mean, we've already made it better because we used some subroutines rather than, as I did it, I repeated the code 3 times. I mean, look. So this is the fill, right? So the first one is there, look. That's the first one. And then I've done it again. There it is. And one more here. And that's why I made it into a subroutine. Everyone spotted it. But we've got the fill in, and it does work. It does work. I mean, it doesn't crash. We'd have to, let's put a, I mean, we could put a shape in there like that, and it should fill that bit. But we still have that problem. But when we make it intelligent, we'll throw different shapes at it, different cutouts, to see if it resolves it. All right then. Well, it's been a good one. We've got 3 commands in there. Oh, we didn't do the thingy test, did we? Right, let me just save this. Save fill to. I think it was sprite 2, wasn't it? Yeah. So we didn't check to see if this worked in graphics mode, did we? So 5 graphic. Right, let's see if it works in graphic mode, see if it puts the sprite on the screen. No. No, it didn't. No, it didn't. Oh yeah, it wouldn't, would it? Got to work it out, haven't we? Got to work it out, because it's not that. He's put the graphic on the screen, but it's not in the right place. Let's work this out. There you go, there's the sprite, but it's the place where I picked is it's taking up some of the high-res screen, so that's a problem. But that's the sprite there. Let's turn multicolor off. So that's halfway down, that's halfway. Maybe we can't have sprites in bitmap mode. Maybe all the available memory's taken up. Let's drop it down. Yeah, that's A, B, C. Let's drop it down. Let's put it at 9F40. So that's what, 40768 minus 8 equals, so that's 8,000. So that's 0.125. So 40768. Let's do that. So we're going to store the sprite data at 40768. Oops. And the sprite pointer is 125. Right. Oh, I've got my sprite pointer wrong. Well, it's not killing it. Right. Clear. 32768. So now that's right. So clear. Pointer 125 times 64. 8,000 plus 32768 equals 40768. That's right. Why is it not showing it then? I wonder. No. I don't know where I'm putting the data now. Ah dear. And so it's 0 to 4, 4 to 8, 8, 9, A, B, C. 0 to 4 to 8, no 8, 0 to 6, no, it's divided by 4, 16K. So that's going to be, 0 to 4, 4 to 8, 8 to 12, 12 to 16. So it's definitely 32 onwards. Ooh. 90768. It's definitely 9F740. Ah, okay. Let's try see. Right, minus 32768. Oh, that's not going to do it. 64. Yep, that's not going to do it. Maybe I can't put. Maybe I can't have sprites in graphics mode. Maybe it's not enough. Not enough memory. Because I think this is the Vic chip picking up the character set. I think this is picking up the character set. Let's try. Yeah, I think that's going to be. I don't think that's going to be able to do it, because I think the Vic's picking up the character set. Aren't sprites blitzed on top of all others? No, the Vic can only. There's certain parts of the memory that the Vic chip just sees the character ROM. So, you know, if you point your sprite to, say, memory that's where the character ROM is normally located, it only sees the character ROM. And I think that's what's happening here, is it's seeing the character ROM. Because like if we, let's say, if we 12288 plus 32768. So if we put it back to what it was, which is 45056, and then change this back to 192. That's using there. It's using the memory that the bitmap would see. But I think here the memory here is actually the character ROM. I think that's actually the character ROM. I think you can demonstrate that using the debugger, I think. Hang on. Right, let's see. So if we put it into bitmap mode, there, look, yeah. So we're using this bitmap here, yeah. But as soon as you cross into this, the Vic chip only sees the character set. It doesn't see the RAM that's underneath it. And so we've put the sprite information under there. Yeah? Does that make sense? So, yeah, I'm not too sure. Unless it's just the bitmap mode that it only sees the character on, but we've switched on bitmap mode. You know, because we're in high-res screen. Maybe in non-bitmap mode, maybe it works. But then again, here, this is normal mode. Now, normally the screen should look like that. That's what it sees in the RAM, yeah? But here, there's data there, and I think that's the character set. I think the Vic chip only gets to see the character set. Let's see, where's the character set? Yeah, so there's the character set there. So even here, look, So if this is the entire sprites array, has it got... well, it's not got a value, has it? See here, it's just black and white. But there, that's where the basic ROM is, but here we're not seeing it. Yeah, so I think it's purely down to the fact that we're trying to put sprite data in here, and it stores it in memory. It's just the VIC chip can't see it because we're in bitmap mode, and it's only seeing the character set, and so that's what's being represented in the sprite. And I didn't go any further here because this is where our code is for the graphics cartridge. Yeah, this is where our code would be, because in the bitmap we start at 10,000 to C1000, so that means that's 9,000, 8,000, and that's where all our code is stored. So we can't really put any sprite information. So sprites, I think the sprite functionality won't work in high res mode, purely because the fact that the where we put the sprites, you'll see it in the bitmap. Oh well, it was worth a try. It was worth a try. Okay guys, I think that's been a good stream. We finally got Phil working. Let's see, who's on? Oh, Typhoid's on. Shall we go and pester him? Alright guys, thanks very much for joining me. And I will see you next time. Take care. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.